Okay, so again, with a sphere of a volume formula is 4/3 times pi r cubed. So the sphere, all we need to know is the radius. That's the only dimension that gives us volume, surface area, whatever we need to find. So again, we'll come back to example 1 at the end. Let's start with example 2. So it says that the drama club is making a big ball from foam to hang above the stage for a play. They plan to cover the surface of the ball with metallic fabric. What is the minimum number of square meters of fabric that the club needs? So it says, recall, the surface area of a sphere is 4 times the area of a circle with the same radius. So what they're telling us here is that if I'm covering something with fabric, I need to find the surface area to equate that to how much fabric I need. And so if the surface area of a sphere is 4 times the area of a circle with the same radius, that means that surface area is equal to 4 times, what's the area of a circle? Let's see. Area of a circle is pi r squared. Okay, so the surface area of a sphere is 4 times pi r squared. Let's write that up with our volume formula so that we have it all in the same spot. So surface area is equal to 4 pi r squared if I have a sphere. So the question is asking us to answer using surface area. They tell us the volume. So the only measurement that we need to find its surface area is its radius. Okay, so we know volume, we want to know radius. So what we can do is use the volume formula and solve for the radius. Okay, so they're telling us that the volume of this sphere is 1.8 cubic meters. And we know that the volume of a sphere is 4/3 pi r cubed. So what we can do is we can take and plug in the 1.8 for our volume and solve for r. Okay, so we're going to take 1.8 equals 4/3 times pi times the radius cubed. And we want to solve for r, and then once we find r, we're going to plug it in to get the surface area. So 4/3 times pi times r cubed. I'm just going to divide out each piece individually. So if I have a fraction, 4/3, I want to multiply by its reciprocal to get rid of it, to move it to the other side. So I'm going to multiply both sides by 3/4. Because 3 divided by 3 makes 1, and 4 divided by 4 makes 1. So those all go away. And on the right-hand side, I just have pi times the radius cubed. And then I need to multiply 3/4 times 1.8. So remember that you can do like 3 times 1.8 divided by 4, or 3 divided by 4 times 1.8, or make a fraction, whatever you do. You should get about 1.35. So our goal here is still to get the r by itself. Right now, the r is being multiplied by pi and being raised to the 3rd power. So we have to move the pi to the other side by dividing first. So let's divide both sides by pi. Which gives us that r to the 3rd power equals about, I'm going to do 4 decimals, 0.4297. Remember that in order to get rid of an exponent, I have to use a root with the same index. So if that was r cubed, I would use, sorry, r squared, I would use a square root. Because it's cubed, I have to use a cube root. So I have to take the cube root of both sides in order to get r by itself. So for the most part on the calculator, if you have something that has a cube root, you might have to hit a second to get it. You can use that. Depending on what it looks like, you might have one that looks like this. And so in that case, you would have to type the 3 first. To indicate that you're doing the cube root. A lot of times it's the space above the function that makes it an exponent. Okay, so depending on how you use cube root on your calculator, you should get 0.75 as your answer. Okay, so make sure you know how to calculate a cube root on your calculator, because again, they're all a little bit different. Now that we know the radius, we can find the surface area and answer the question. Okay, so we're going to plug our 0.75 into the 4 times pi r squared formula that we know for surface area. So the 0.75 is going to go in for r in this equation. So we have the surface area is going to be equal to 4 times pi times that number squared. And so this, I have all numbers on the right-hand side, so I can just plug that into my calculator. And so I'm calculating out 4 times pi times 0.75 squared, which gives me about 7.1. And so remember, we're talking about fabric, so this means that the club needs about 7.1 square feet of fabric. Okay, so just to kind of recap what we did, the first thing we had to do for this problem was find the radius. And then we could use R to find surface area. On your problems, the first couple give you R, so you're just plugging into the surface area formula. You only have to do step 2, and then once you get to the second, like there's 2 of them like that, and then there's 2 more where you have to do everything. It turns out a little easier than that. Okay, so let's look at example 3. So example 3 is talking about hemispheres. So hemispheres are the dome shape that's created when you cut a sphere in half. So a hemisphere is half of a sphere. And so if I think about the idea, volume is going to be half the volume of the sphere. I'm just going to blame it on being sick. Of the sphere with the same radius. So if I had this whole sphere, my volume would be 4/3 times pi times my radius is 4 cubed. But it's only half of a sphere, so I know that the volume is going to be half of that volume. So if I think about that generically, can I simplify half of 4/3? So if I ignore the pi and the 4 cubed right now, I have half of 4/3. Can I reduce the 2 with the 4? And so that'll give me really a 1 times the 2/3. So I can think about this as 2/3 times pi times 4 to the 3rd power. So if I remember that, then I don't have to calculate as much as I did right here where I had to figure out that value, right? So I would have less to plug in my calculator if I remember that a hemisphere is 2/3 pi times r cubed. So let's write that at the front before we calculate. So a hemisphere has volume equal to 2/3 times pi r cubed. Okay, so we can use that instead of having to multiply it by half every time. Okay, so then if we go back to that problem, we have to calculate 2/3 times pi times 4 to the 3rd power. And so if we do that, our volume is about 134.04, and they don't give us any units, so we want to just write units cubed. Yeah. I simplified the fractions at the top so that we don't have to now do it again and calculate the 1/2 times the formula for the next one, so that we can just use 2/3 instead. So no, you could just plug it straight in your calculator every time, but I was trying to save like that calculator calculating. So now for the next problem, instead of using 1/2 times 4/3, we're gonna go ahead and see hemisphere and just do volume equals 2/3 pi r cubed. That was the only reason I did that. So in this question, they don't give us radius. What do they give us instead? Diameter, good, which means that the radius is half of that, so 6.5. So we're going to plug 6.5 in for the radius in our equation, so 2/3 times pi times radius cubed. And that should give us about 575.17 cubic feet. Okay, so now that we've talked about hemispheres, I want to go back to example 1. We're going to actually calculate the volume. Let's just kind of talk about how they're changing and what we know about the formulas for each of them. So for example 1, it's asking us to find the volumes of the 3 solids and to explain what we notice. So just looking at the problem, notice that all the dimensions are the same. My radius for each of them is 10 meters. And my height for each of them is 10 meters. So if I think about the hemisphere, the radius still is the height of that hemisphere, right? It's still 10 meters. So I can think about it as they all would fit in the same box, right? So if I had a box, I could put them each in that same box. It would have the same width on the base and the same height, and they could all fit inside that. And so the volume formula that we have for a sphere that we just talked about for a hemisphere is 2/3 times pi times our radius for this one is 10, so times 10 cubed. For the cylinder, our height is 10 and our radius is also 10. What's the volume formula for a cylinder? Remember, for cylinders, the prism is always the area of the base times the height. So what's the area of a circular base? Pi r squared. So it's going to be pi r squared times height, which would be pi times 10 squared times 10 for this problem. For the cone, we have the same height and the same radius that we have for the cylinder. Remember that a cone volume is just the cylinder's volume times a fraction. What's the fraction? It's 1 over something pi r squared h. 1 over 3. So in this case, it would be 1/3 times pi times 10 squared times 10. So looking at these, they all kind of have a lot in common, right? They each have a pi. what else do they each have? Don't they all technically have a 10 to the third power? So this one has 10 squared times 10, and isn't that 10 to the third? And then 10 squared times 10 again is 10 to the third. So I can kind of relate all of these to the cone, because the cone's the smallest. So notice that I would just multiply the volume of the cone by 3, and that would give the volume of the cylinder. Okay, so the cylinder is 3 times the size of the cone. And then how much bigger than the cone is the hemisphere? So I have to multiply the cone by to make it the same space as the hemisphere. A 2. So see how that's 2/3 instead of 1/3, right? I double it. So the hemisphere, bless you. So the hemisphere is 2 times the size of the cone. And so then that relationship will always be true. So if I have something that has those same dimensions, the same height and the same radius, the cylinder is always going to be 3 times the size of the cone, and the hemisphere is always going to be twice the size of the cone. If we had instead a whole sphere, how much bigger than the cone would it be? 4 times. Good. So our volume formula is 4/3 instead of 1/3, so it's going to be 4/3 the size. Okay, so the last piece that we're going to talk about is composite figures. So composite figures are when I have multiple 3-dimensional objects put together or taken apart in order to create a space, and I want to find something about it. So in this problem, we have a solid composed of a right cylinder and a hemisphere. If the density of the solid is 100 kilograms per cubic meter, what is the mass of the solid? So they're asking us for the mass. All that we know is how to find the volume of something, and they give us density. So what is the relationship between density and the volume in order to get mass? Like, do we have a formula where mass equals something to do with density and volume that we remember from science? What is it? We don't remember it. We know there is one, though. Yeah. Close. It's mass times volume. No, you're right. Sorry, you're right. Density is wait, which one? Volume over mass? Mass over volume. Okay. So we need to find our mass. We know how to find our volume. They gave us density, right? So they gave us that 100 kilograms per cubic meter is our density. We want to find the mass, and we can find the volume. Okay, so let's find our volume first. So if I think about my shape, I have 2 pieces. So I'm going to have to find the volume of the hemisphere and the volume of the cylinder separately, and then I'm going to add them together. Okay, so my volume is going to be whatever the volume of the cylinder is plus the volume of the hemisphere. Okay, so we just talked about the formula for volume of the cylinder. It's pi times radius squared times height. And then for a hemisphere, we said is 2/3 pi times radius cubed. So looking at our cylinder, what is the radius? 1. Good. So they're telling us that the diameter is 2, so that means the radius is 1 meter. So we got pi times 1 squared times our height is 3. And then let's just calculate that value before we go to the hemisphere. So if we calculate that volume for the cylinder, pi times 1 times 3 is going to give us 9.4. So we have about 9.4 cubic meters. Plus the volume of the hemisphere is going to be 2/3 times pi times the radius cubed. And so what is the radius of the hemisphere? It's also 1, right? They're sitting together perfectly, so they have the same radius. And so we're really just doing 2/3 times pi because 1 to the 3rd power is still 1. And so that should give us about 2.1. So we've got 9.4 cubic meters plus 2.1 cubic meters. Tells us that the whole shape has the volume of 11.5 cubic meters. And so remember that we want to find the mass of that shape, so we're going to plug our volume into our density equals mass over volume. So we're going to do 11.5. And then to solve for m, we have to do what to both sides? Multiply by 11.5. So if we multiply by 11.5, that's going to go away. And then remember that the idea is that our units, the meters cubes, end up canceling. And so we get 1,150 kilograms for our mass. Okay, so let's try it together, kind of talk about what information they give us and what we need to do, and then I'll have you guys work on it and calculate yourself. So we have a cylinder with a sphere inside of it. So it says if the height of the cylinder is equal to the diameter of the sphere, so they're telling us the height here is equal to the diameter of our sphere, how tall is the cylinder? So they told us the radius of the sphere, right, is 12. So that means that the height must be 24. So 2 times 12 gives us 24. What is the volume of the space between the sphere and the cylinder? So it's asking you for the volume of the empty space. So all that space around the sphere. If the radius of the sphere is 12 centimeters, what is the radius of the cylinder? Is it different? Because it fits inside perfectly, right? So this radius here is also 12 centimeters. So because the sphere is inside the cylinder, I'm not going to be adding two volumes together. I want to find the empty space between them. So I want to find their difference. Okay. So in order to do this problem, we have to subtract our volumes instead of add them. Okay. So take a minute and do that. So you want to find the volume of the cylinder because it's the outside shape, and then subtract the volume of the sphere. Remember that it's a whole sphere, not a hemisphere. And so that's going to change the value that, or the equation that you use for that. Okay, so take a few minutes and plug in and calculate. I'll put like the final answer up so that you'll know if you did it correctly.